Hello chemists, we're going to take a look at drawing covalent Lewis structures. And we may have remembered from a previous unit that fluorine likes to form a diatomic molecule. So fluorine makes a diatomic molecule. There's others like chlorine and hydrogen and bromine and iodine. But let's just take a look at fluorine and try to rationalize why does it form a diatomic molecule like this. Now, if we take a look at our periodic tables, we'll see that fluorine has 7 valence electrons. And I'm going to draw those around the fluorine atom here. And if we imagine like there's a box, like an imaginary box around this fluorine atom like this. And as we draw those 7 valence electrons, I'm just going to go like this. I'm going to put one dot around each side of the box. I'm going to go 1, 2, 3, 4. And then now I've run out of sides. I'm going to have to double up here. And so I'm going to go 4, 5, 6, 7, like this. So 7 valence electrons. And to be stable, atoms tend to have 8 electrons in their outermost shell, 8 valence electrons. And so for this to be more stable, it would just need one more. I'm going to draw a second fluorine atom here. And I'm not going to put the box around that. I'm just going to put in my valence electrons. I'm going to go 1, 2, 3, 4, 5, 6, 7, like that. Now, if we imagine that these two fluorine atoms could somehow come together and share these 2 valence electrons, then each of them might have a stable octet. So I'm going to redraw this here. I'm going to put my 2 fluorine atoms a little closer together like this. And I'm going to put in my electrons. Like that. And we can see now that we have electrons being shared between the 2 fluorine atoms. And we have these other electrons out here that are not being shared. And so we have special names for these. We would say that these ones here that are not being shared, these are called lone pairs of electrons. Lone pairs of electrons. And then the electrons that are being shared here, these are called bonded pairs. Bonded pairs of electrons. The next thing we'll take a look at is water. Now we might remember that water has this formula of H2O. Go H2O. And let's try to make sense out of this. I've got an oxygen atom and I have 2 hydrogens. So let's take a look at the Lewis symbols for hydrogen and oxygen. So oxygen, if we take a look at our periodic table and we see how many valence electrons it has, we'd see that it's 6 spots over. And so oxygen here would have 6 valence electrons. I'm going to go 1, 2, 3, 4, 5, and 6 like that. And then hydrogen has 1 valence electron. Looks like that. And we can see here that if hydrogen were to come over and combine with this oxygen, they could share electrons here. And then oxygen would have 6 plus 1 would be 7 electrons around it. And if we were to add just one more hydrogen, add one more hydrogen over here, like this, if this hydrogen and this hydrogen were to come together with the oxygen, then all together we might fill that octet for the oxygen atom. And so let's try putting all of this together here. And we'll have an oxygen like this, a hydrogen, and a hydrogen like that. And then put in all of our electrons like that. Here we go. We can see now that oxygen has a complete octet, 8 electrons around it, and the hydrogen atoms here are sharing with the oxygen atom. And one of the questions students often ask is, say, well, why doesn't hydrogen have an octet? And that is a great question. Hydrogen is a very, very small atom. It's up on the upper left-hand side of our periodic tables. It doesn't have enough space to have an octet. There's not enough room there in that tiny little atom to have an octet. And so it's one of those exceptions. It's satisfied with just 2. Now, using these Lewis symbols like this and making the Lewis structures now, we can see why we would have 2 hydrogens and an oxygen combining to make H2O. The next one I'd like to take a look at is carbon tetrachloride. Carbon tetrachloride is going to have a formula like this. So carbon tetrachloride. Oh, let me go like this. Carbon tetrachloride, like that. It's carbon and then 4 chlorine atoms. So that's the formula. Let's try doing the Lewis structure for that. So we're going to put carbon here in the center, like that. And I'm going to put in my valence electrons. And carbon, if we take a look at our periodic tables, has 4 valence electrons. So I'm just going to do my imaginary box here. I'm going to put 1 electron on each side of the box like that. There's my carbon Lewis symbol. And then my chlorines. So chlorine, I'll put 1 here like that. Here's my chlorine atom. And I take a look at my periodic table. I see it's in group 7. It's got 7 valence electrons. So my imaginary box here, I'm going to go 1, 2, 3, 4, 5, 6, 7 like this. And now I can see, all right, chlorine looks like it needs just 1 more electron. It's got 7. It would like 8 to satisfy that octet rule. We could share 1 here with the carbon, and that would satisfy that chlorine. But carbon still needs some more. So if I were to add some more chlorines to this carbon, like this, and add those valence electrons. Each one of these chlorines is going to have 7 valence electrons, just like this one here. Like that. We can see how this all comes together, where we have sharing between the carbon and the chlorines now. We'll have 2, 4, 6, 8 electrons around here, around this carbon atom. And then each one of the chlorines would have 2, 4, 6, 8, satisfying the octet rule for each of the chlorines. And so that helps us to explain why chlorine, or carbon tetrachloride, is CCl4. Now, sometimes what chemists will do is they'll get a little bit lazy and they don't like to put all these dots in here. And where you'd have 2 dots forming a bonded pair between atoms, they would just get a little bit lazy here and draw a single line like this. And you might have seen this before in chemical structures, maybe reading in a book or someplace like that, or on the internet, you might see something that looks like this, where we just draw lines like that. And that's to represent our bonded pairs. And if you can imagine like 2 electrons, right? 2 electrons in each one of these like that. It's just the lazy way of drawing that out. Now, the last thing we'll take a look at is multiple bonds. So up to this point, we've just done a single bond, a single bonded pair between 2 different atoms. But sometimes we could have multiple bonds between atoms. And an example of this would be oxygen and nitrogen. So I'm going to do oxygen. Oxygen is one of those diatomic molecules, and so is nitrogen, like this. We know that this is the formula for these, so how do we rationalize that using our Lewis structures? Well, let's start out with oxygen. Now, oxygen, if I do an oxygen atom, I'm going to see that it has 6 valence electrons. And so I'm going to put those in here. I'm going to go 1, 2, 3, 4, 5, 6, like that. And I'm going to do another one of these here, another oxygen atom, and put in my valence electrons. 1, 2, 3, 4, 5, 6, like that. Now, we want to share electrons to somehow figure out how to satisfy the octet rule for both of these oxygen atoms. And right away you might see, okay, well these two here, we can share those. Okay, so let me just do that. I'm just going to erase this here. I'm going to share these two electrons. I'm just going to go like that, share those two electrons. And now each oxygen atom has, by sharing, 2, 4, 6, 7. And then this one here has 2, 4, 6, 7. So we're almost there. But we can't add any more electrons to this, so how are we going to make this work? And you might look at this and go, wait a minute. You've got a single electron here, a single electron here. Let's share those. And you'd be right. So we can bring those in here. Just going to erase that one there and erase this one here. And then I can put them in the middle like that. And when I do that, now I have 2, 4, 6, 8 electrons on this oxygen atom and 2, 4, 6, 8 electrons on that oxygen atom by sharing covalently. And so that satisfies the octet rule for both of these. And sometimes chemists get lazy and they don't always draw out all the dots, and so they might draw it like this, where they just make a single line like that, single line like that, and they show this as a double bond, A double bond is sharing 2, 4 electrons covalently between two atoms. Now that we've seen a double bond between two oxygen atoms, let's see what happens with nitrogen. Nitrogen is a diatomic molecule. It's going to have 2 nitrogen atoms. So I'm just going to put my 2 nitrogen atoms here, nitrogen and nitrogen like that. And I look at my periodic table to figure out how many valence electrons I have, and each nitrogen will have 5. So I imagine a box around here, and I put in my 5 valence electrons like this, 1, 2, 3, 4, one on each side of the box, and then just randomly, I'm just going to pick my 5th one over there. Do the same thing with this nitrogen atom, 5 valence electrons, 1, 2, 3, 4, 5 over here. Now I have to somehow share electrons so that way each one of these nitrogen atoms ends up with 8 valence electrons. Right away we can see 2 here. So let's put those together and make a bonded pair between the atoms here. Let's go like this, and I'll just go like that and like that. Okay, so there's one bonded pair, and so that way this nitrogen atom has 2, 4, 6, and this one has 2, 4, and 6. So each of these has 6 electrons by sharing, but that's not enough. We need 8. So let's do some sharing like we did with the oxygen over here. I can take maybe these 2 here and bring them in and share them. Go like that, okay. So now I have what looks like 2 bonded pairs here, and each one of these nitrogen atoms has 2, 4, 6, 7. We're almost there. We just need one more bonded pair, it looks like. So I can take these lone electrons, bring them in like this, bring them in, and now like this. Okay, now by sharing these 6 electrons, each of these nitrogens has 2, 4, 6, 8 electrons around it. Wow. Now, if I were to draw this just kind of lazy, what I might do is put my 2 nitrogens like this and like this. I have 6 pairs of, I've got 3 pairs of electrons in here being shared. So I might draw that as 3 bonds like that, 3 bonded pairs. And I've got my lone pairs out there, and then just to kind of make it look pretty, and this is just kind of my OCD, I'm just going to put them out on the outside there just to kind of make them look symmetrical. But now nitrogen here makes a triple bond between the nitrogen atoms, and that's how we rationalize that with Lewis structures, N2. Now, this is one of those places where my students often ask me, okay, Professor Locken, you've shown me single bonds, you've shown me double bonds, and then here triple bonds. So triple bond, I'll just go like this here, triple bond. A triple bond here. You've seen that now. Can we have a quadruple bond? And that's a great question for my students often ask. And as it turns out, no, we don't see quadruple bonds in chemistry. It's just single bonds, double bonds, and triple bonds. So if you ever see a quadruple bond, you know something ain't right.